This is not a typical tech review of the Leviton DZPA1. This is my point of view as a home automation enthusiast from a gardening perspective after using the product for more than 5 years. I'm growing tropical plants in a temperate climate where temperatures always reach double digits below freezing point during winter, with or without global warming. So from my point of view, it's never too early to get ready for the next season. It's like going to a big box store in the middle of the summer while still on vacation and seeing that they have already rotated the inventory for fall and winter stuff. It can be depressing, but when I'm in control, I don't really care what they have in store for me. The key for me is to have a system in place that streamlines the transition between seasons for my tropical plants. My specific use cases involve two environments: a greenhouse in spring and summer, and a heated garage in fall and winter. Basically, I bring some of my tropical plants from the garage to the greenhouse in spring and from the greenhouse to the garage in fall. There certainly are many ways to build a system that will facilitate the transition between these two environments. The approach I chose is based on modularity. Arguably, it's not the approach with the simplest implementation. For example, it's easier to get a programmable heater with an integrated thermostat than setting up a Z-Wave network that includes a sensor, a switch, and a heater. Depending on the components selected, a modular approach may not be the cheapest approach either. For example, programmable heaters with an integrated thermostat can be found for less than $50. With that in mind, a modular system is more versatile. For example, a heater with an integrated thermostat is pretty useless inside a greenhouse in summer. At best, it can be used as a fan. A modular system also offers more control. For example, a heater with an integrated thermostat used in fan mode in a greenhouse during summer cannot be controlled based on humidity level or sunlight condition, unless the heater also integrates additional sensors, in which case the price tag on the heater will certainly be much higher. Even if the heater integrated multiple sensors, the user interface to fully take advantage of all the sensors and possibilities will be probably too complex for the average user. Now, I'm not saying that you have to get up to that level of customization in order to successfully grow tropical plants outside of tropical and subtropical regions. But in case you happen to be a home automation enthusiast, the Leviton DZPA1 has some interesting characteristics to consider. Superior versatility and control require components that are very good at what they do. I made a video about the Z-Wave protocol and why I still think it's the best protocol out there for home automation. You may want to watch that video. I also reviewed the AOTech Multisensor 6. You may want to watch that video too. In this summer setup, I used the Multisensor 6 to decide when to turn the DZPA1 on to power a dumb fan. The dumb fan cost me almost nothing, as it comes from a broken microwave oven, and I 3D printed the fixture and blade protection parts. The thinking here is that the real value of the setup is in the intelligence that commands the components, not in the components themselves. Just as the Multisensor 6 is very good at sensing, the DZPA1 is very good at a simple task: switching the power on and off. First, it's a 3-prong outlet, so it works with devices equipped with 2-prong and 3-prong plugs without requiring an adapter. The 3-prong outlet indicates that it provides some level of surge protection. Looking at the specification datasheet, the manufacturer indicates that the DZPA1 provides both surge protection and electrostatic discharge, or ESD, protection to level 4. The datasheet is not clear, but I assume surge protection is based on IEC 61045 standard, and ESD protection was tested with IEC 61042 standard. Surge protection refers to high peak voltage with high energy over a relatively long duration, from a lightning strike close to an underground electric cable, for example, while ESD protection refers to high peak voltage but low energy discharge over a very short duration, from human contact or high humidity level, for example. My greenhouse is powered through an underground electric cable. Although the DZPA1 was not specifically designed to operate in a greenhouse, it's relatively safe to use it there, thanks to its ESD and surge protection. Just like my other electric equipment that are not ruggedized, the DZPA1 is located close to the ceiling to reduce risk of splash when I water the plants. I did not test surge and ESD protection, but I can say that over the last 5 years, I have had no equipment malfunction with electric equipment plugged into the DZPA1. For extra protection, the DZPA1 can be plugged into a power bar. I have used the DZPA1 in both configurations, plugged into a power bar or with a power bar plugged into its 3-prong outlet. Plugging a power bar into the DZPA1 allows multiple equipment to be switched on/off at the same time. The main use case for this is switching on/off multiple lights, but multiple equipment can also be switched on/off individually with a single DZPA1. For example, a dumb fan plugged into the DZPA1 can be turned on based on the time of the day, say between 12 p.m. and 4 a.m. If a heater with a thermostat is also plugged into the same DZPA1, that heater can be programmed to turn on only when the temperature drops below 5 degrees Celsius. So during the day, the fan alleviates the heat inside the greenhouse. It can get pretty hot in a greenhouse in the fall on sunny days. And at night, the fan and the heater ensure a better distribution of the heated air. The use case above could also be implemented with a programmable outlet like this one. But what if instead of current time and ambient temperature, the two parameters were humidity and luminance? Typically, programmable outlets like this one are designed to power various types of lights. I still use them for some of my indoor grow lights. They usually have a more limited current switching capacity, like 10 amps. The DZPA1 can power lights, but also appliances and motors, as it can provide 15 amps or 1800 watts at 120 volts, and sufficient energy to operate a half horsepower motor. With 1800 watts of capacity, in early fall I can plug a small 1500 watt heater placed on the ground and still have enough power to operate the fan in the ceiling to better circulate the warmer air as it moves up. A half horsepower motor can lift a 12-foot garage door, so the DZPA1 can easily operate a motor to open and close the door of a greenhouse for better ventilation, for example. In fall and winter, I use the DZPA1 in my garage to power the lights for my tropical plants. With regards to lighting, the DZPA1 can supply power up to 1800 watts for incandescent bulbs and 1800 volt amperes for fluorescent lights, taking into account the reactance component of fluorescent lighting circuitry. For LED lights, the capacity of the DZPA1 is rated at 5 amps or 600 watts at 120 volts, which is a third of its switching capacity for incandescent lights. This lower switching capacity for LED lights is normal and on par with the competition. 600 watts of switching capacity means that one DZPA1 can operate 15 40-watt T8 LED lights, each producing 5000 lumens, enough to light up a wide area. My current garage setup has only 12 T8 LED lights plugged into one DZPA1, just to stay safe. I have not experienced any issues for the last couple of years with this setup. The DZPA1 has a push button that allows manual override. The button is lit up when the device is turned off, which is convenient when you are in the dark and want to turn it on. The DZPA1 requires a hub with a Z-Wave interface. In the garage or in the greenhouse, the connectivity to the Z-Wave network has never been an issue. One last point with regards to cost. Shopping for a DZPA1 on Amazon can sometimes be misleading. In Canada, it's directly sold by Amazon for almost $100 after taxes, while other specialized online retailers have the same product for less than half that price. Amazon is often not the best place to shop for Z-Wave products. If you want some elements of answer as to why, check out my comparison between Thread and Z-Wave protocols. Thank you for watching. For more content on this subject, like and subscribe or drop a comment.